I am Ashish Kumar Panda. I work as a senior data scientist at Epsilon. Along with me is my co-author Gaurav, who works as a data scientist at Epsilon. So today we will be going through an interesting topic on steering e-commerce success through next basket recommendation system.
So Epsilon is a printer.
Yeah, sorry.
Not some other pharma or something.
No. Epsilon, no, not the printer company. Epsilon is like a marketing company.
Okay.
We are into marketing, digital marketing. So here is the overview that we are going to work through. So we will be walking through the overview of next basket recommendation system, its application, the methodologies, how we have defined the problem, and the evaluation metrics, and we will conclude with it. So what is next basket recommendation? It is a specific type of predictive model which is being used to predict the entire next set of items that a customer is going to buy in their next transactions. Why is it so important? So first thing is like personalization. Using this we can give tailored recommendations to the users. Customer retention, like by anticipating the needs of the customers in advance, we can build a long-term relationship with the customer. From business implications, we can this helps in like driving customer loyalty, personalization, and sales revenue through targeted promotions. And finally, revenue growth. So helps in like driving upselling and cross-selling.
So sorry to interrupt. To get clear idea. During the first purchase, you're trying to predict what he's going to buy in the next purchase, or after the purchase is made, you're trying to recommend something. That's the difference.
Both the case.
It will be India. If you go and put something in Amazon cart, it recommends something. You're talking about that, or after the purchase. After the payment is done, after the order is done, then you're recommending something.
After the order is done, coming to your point. So the application is mostly in like big basket predicting shopping carts or like Zepto or Swiggy Instamart, where like we purchase on a very regular basis, and the algorithm understands our purchasing pattern and like anticipates in advance, like okay, these are the items that this person might buy next. Like we purchase like grocery.
Market basket analysis.
But market basket analysis.
Because I'm trying to understand that how is different from market basket. Since you use the word next, I'm trying to understand that.
Yeah, next in the sense is like what's the next set of items that I'm going to buy? Not like one item or two items. The whole next set of items.
Okay, fine.
Whole next set of items. Coming to the problem definition and methodology. So here what we are doing is like, so here like we are looking into the historical records of each of the users, and we use that to predict the next set of items. And the predictions that we are doing, we will compare with the ground truth basket, which is basically the last transaction that the customer has done. And for this, like we are using like two different methodologies. One is like our baseline models, and one is our challenger model. This is the most important thing that we'll talk in this session. In the baseline model, we are going through like global top frequency, personalized top frequency, and global personalized top frequency. And in the challenger model, we will be explaining TIFU-KNN, which stands for temporal item frequency user-based k nearest neighbor algorithm. In the next couple of slides, like my co-author Gaurav will walk you through. So please Gaurav.
So I'll talk about the three baseline models that we have implemented in our paper. The very first one is the global top frequency recommendation. What it does is, this method actually suggests users the globally that is the overall purchase frequency across all users. The items which are globally most purchased across the entire data set. And so basically what we do is we select the top k most frequently bought items for every user, and then recommend it to the user on a global scale.
So what are those items?
Sorry?
What are those items?
Those items
I'm understanding, is there any scope, like groceries, electronics, or it's general?
Yeah, it's generic.
Okay.
So the pros, like the advantages of this model is that it's simple, meaning it's easy to implement, it's scalable, and it has a cold start solution, meaning if a user is has not done any past transactions, it still will actually be able to recommend it to the users because it is using the globally most frequently bought items. But the disadvantages of this model is that it lacks personalization. It might not be able to give individual user preferences, But yeah, so the other one is the popular bias. So what? Yeah, no, no, so the popularity bias mostly what it does is it overemphasizes on the popular items, but it will mostly ignore the niche items that are present in the data set. So next we'll discuss about the personalized top frequency recommendation. So this method, what it does is it selects the top key items based on a particular user's historical transaction. So this is on user level. The previous one was on the global level. So here the advantages of this model is that it has high personalization compared to the previous model that we were using. The second one is that it leverages the predictable pattern. So what this model will be doing is it will work better for those customers who have predictable pattern when purchasing an item from a grocery shop or anything. And the third one is that it's simple and easy to implement. The disadvantages or the limitations of the model is that it lacks variety, because it might not be able to understand if what is the popular trend or the global trend that is going right now. The second one is that there will be no cross-user insights. So let's say there are two users, user A and B. User A has purchased X item. So a model what it should have done is, if user A and B have similar buying pattern, user B should have been also recommended that he should buy X item. That is actually collaborative, but this is not done here, which we'll be doing in the more advanced model, that is TIFUKM. So that is one disadvantage of this model. Next we'll go to the globally personalized top frequency recommendation. So this model, what it does is it combines the strength of the two models that I discussed earlier, that is the global top frequency and the personalized top frequency. So it actually balances out the personal preferences as well as the global preferences. So that's what I'm talking about, the balanced recommendation. And the second one is that it will solve the problem of cold start, which will be there in the personalized top frequency. So here there will be no problem of cold start mitigation, because it will handle the cold start problem using the better than the peak of frequency by leveraging global data. The disadvantages or the limitations will include that it's quite complex and it will require a lot of balancing to actually balance both the personalized preferences as well as the global preferences. Now I'll call over Ashish to explain about the thing.
Okay. So like as I was discussing before, this is our challenger model, which stands for temporal item frequency based user k nearest neighbor. So this uses like the temporal dynamics to prioritize like the recent purchases and combines this personalized preference with the collaborative recommendations to recommend the products. Okay, so what are the key components of TIFUKM? I will try to simplify it in a very simple manner. So one component is coming from like the user preferences. So what are the most repeat items that the user is purchasing? So from there we can say like, okay, these are the items that should be suggested. The second is like the collaborative component, where it is coming from the nearest neighbor insights. So what are my like-minded users are purchasing? So we'll get some product recommendation from there. Then we'll combine these two to give us the final predictions. And we'll go into each of these components in detail. So like first is like the personalized insights. In this we are using like two decay effect. One is like temporal ripple effect and temporal fracture effect, which we'll discuss in detail.
But that's how the recommendations are running as of now with the fashion platform, right? Fashion platform, any of the apps that you see.
Yeah.
It is the same kind of methodology it is inculcating SR.
Yeah.
How different is yours?
Yeah. So we can
It is
explain.
a very personalized recommendation that you get.
True.
Or in a Myntra platform.
True.
Or a Zero.
Yeah, so I will explain it in the next two slides to answer your question. Okay. So that personalized insight, when I said it is like very simple, the repeat items that is being suggested to me. Okay, right? But it's not that simple over here. So here we are using something known as like the temporal ripple effect. So when we think of ripple, like throwing a stone in the water and there is a ripple being created, and the nearest part of the ripple has more power as compared to the the later part as it move outwards. Similarly, here say like Hari, who's a customer of say like my e-commerce store. I have like say like 20 items. So Hari has done like 3 transactions over here, and in the third transactions, whichever item has been purchased will be given more weightage, and in the second transaction, whichever item has been done will be given less weightage, and in the first transaction, which is like earlier transaction, the least weightage items will be given. Okay. So say like Hari purchased in third transaction item 1, 2, 3. So more weightage will be given to those items. And say like 1920 item has been in index number 19th and 20th has been purchased in first transaction, that will be given the least weightage. Now like the how this one helps is basically this helps in like giving like contextually relevant recommendation. Recent purchases means like it caters to like the most immediate needs, and also this helps in avoiding like irrelevant items tied to outdated patterns. Okay. Now this one is like our key, like one of the most important part that I would like to explain. Here like we are using the concept of temporal.
So how do you assign the weightages for these transactions? The repeated purchases that made for the particular item, or how are you putting the weightages for these items?
Yeah. So say like so we say like we have a weight decay effect here, like we say like within group decay rates, that will be like say like 0.9, say like for example 0.9. So if the user Hari has done has purchased like out of the 20 items in my e-commerce store, has purchased item 1, 2 and 3, then in the third transaction, then those 3 items will be given 0.9 to the power 0 in their corresponding positions. And the earlier transaction, in second transaction, say like he has purchased item number 5 to item number 10, so then those indexes will be given 0.9 to the power 1 over there. And similarly, the least weightage will be like 0.9 to the power 2 and so on and so forth. That's how like in that index we are giving the the weightage value, and we are creating something like we are replicating something like the embedding vector. I will explain it to you. Like we will be creating a profile for Hari. We will be creating a profile for Hari that will represent like his purchasing pattern. I will explain it to you in a moment. Okay. So here what is happening is like we will be now combining both temporal ripple effect and temporal fractures effect. So what is temporal fractures effect? So here it is this represents a time-based grouping of transactions capturing user behavior that is specific to certain period. So these fractures allow the system to understand that user preferences are often dynamic and heavily influenced by external factors such as celebrations, festivals, or specific life events. So let's go into the same example of Hari. Here Hari has done like say 10 transactions. Okay, 10 transactions being the most recent and first transaction being the very earlier transaction. So as I was saying, more weightage is given to the items that have been purchased in the 10th transaction. So like 1, 9, 2, or 0, those indices. Each indices represents the products that Hari has purchased. Okay. And then what we are doing is like we are creating fractures. Fracture is basically group. So the first 3 transactions we are doing a group. Then the next 3 transactions and the last 4.
This makes sense.
Okay.
Yeah.
And then finally we are giving some weightage to the recent fractures and earlier fractures, and then we are summing it up into a final vector. That final vector will be of length 20 because I had 20 items, and those items which had like more weightage will be actually recommended to Hari from like personalized insights component I was talking about. Okay, here I just want to explain like why this temporal specific fracture is very important. So say like I celebrate Diwali with a lot of components, so and just 1 week before Diwali I start purchasing items. So what happens is like during a festival like Diwali, I will order like candles, diyas, sweets and so on and so forth. But these purchases are very specific to the festive season and doesn't reflect my usual preference. Usually I will purchase grocery items mostly, but yeah, during Diwali I will be purchasing most of these Diwali specific items. So what PIFU canon will do is like it will create a Diwali specific temporal fracture where it will group all the transactions related to that festival into one group. And it will assign a high group decay rate to that Diwali fractures, and during the festival season, it will the system will understand and recommend more similar kind of items. And once the festival ends, and that fracture will go above, and there will be a new fracture that will be created. So that fracture will be getting like less weightage, and once that will get less weightage, and the recent transactions where I generally purchase like grocery items and so on and so forth, that will be given like more weightage. So the system will automatically reset back to the normal conditions where it will actually suggest me like my usual preferences. So that's why like this temporal fracture comes into plays a very important role. So that was the personalized insight component, and similarly we will be looking into the collaborative component where like similar to Hari, there are like 4 other people like Sailesh, Shyam, Ram, Sabya, and those 4 people will be having like similar kind of say like using KNN component, we are figuring out these are the members who have the similar kind of user preference as Hari. So those the items that they are purchasing, we will be having similar kind of vector like that vector that I was talking about. We'll sum up those vector, and the items that will be having like more weightage will be recommended back to Hari. So that is coming from the collaborative component. Now once we have like the, so this equation is one of the important equation. Once we have like the collaborative component, and once we have like this personalized component, so basically some recommendations is coming from this collaborative component, and some recommendation is coming from the personalized users component. So we'll be assigning some alpha hyperparameters, say like 80% weightage is say like will be given to like personalized insights, and 20% to the trends that is happening between the similar user preference people. So that will give us the final predictions, and that vector, from that vector we will recommend the items to the target user, which is Hari.
So how do you account the new user?
Yeah, so say like when you select totally new user, then it is a bit tough. But if you say like there is a user who has purchased, hardly done one transaction, where he has purchased like 5 items of the same frequency, one item. So personalized insights won't be able to give like proper recommendation, but this collaborative insights will be able to give us like more recommendation from similar kind of user. But at least the user should have done some purchase for this to kick in. So yeah, so the importance of this final prediction. So as I was discussing it in the past few slides. So it balances personalization and generalization. It basically we see like personalization is coming from like the personalized insights, and generalization is coming from the collaborative component. Similarly, it will be easily handle like dynamic user behavior using the temporal fracture and temporal ripple effect. And yeah, like cold start mitigation problem, like you are asking the question like for people with limited data, how we will deal with it. And yeah, diverse recommendations also we will be able to suggest to the user. Yeah, now coming to the part of like on the basis of what we judge the quality of the models. So we judge the quality of the models on 3 different metrics: recall, prediction hit rate, and NDCG. So on recall, basically it says like how many relevant items are recommended to the user. So if you see like in the graph, like for TIFU-KNN, we are getting the maximum recall followed by G-bit of frequency, then P of frequency, and G of frequency. Similarly, when it comes to NDCG, it basically says like out of the items that we are suggesting, how many relevant items are coming on the rank 1. So how well the items are being ranked while suggesting to the users. So on NDCG factor also we see like TIFU-KNN outperforms all other baseline models, and yeah, similarly in the other metric. The final one is like prediction hit ratio. So basically prediction hit ratio is like how many of the percentage of predictions actually matches with the outcome. So over there also we see like the TIFU-KNN has outperformed all other metrics, like say like G-bit of frequency, P of frequency, and G of frequency. And hence we reach to the conclusion like where we have applied TIFU-KNN to this next basket recommendation system, and we see like how TIFU-KNN model has outperformed all other models in terms of like recall, precision, hit rate, and NDCG value. And this approach not only boosts like the upskilling and cross-selling part, but also like helps in giving like growth to the sales revenue, and also brings loyalty to the brings the loyalty of the customers, and also helps in like giving like the highly recommended products. With that, I thank you. Thank you.
Have you used this? Have you tried with your?
Yes, Lord.
So yeah, it's in the pitching process right now. We will be very soon deploying it. It's in the process going on.
Okay. No. Have you tried internally with your
On
team
a-
members building it, closely using it with your friends and colleagues,
No.
designing this?
No, it's in work in progress right now.
Okay.
We haven't reached that stage yet, but yeah, like
Okay.
we have conceptually implemented it on a sample of data, and we have found some good results where like we see like TIFU-KNN is outperforming most of those baseline models,
Okay.
and hence we are considering it as a challenger model.
Any questions?
The performance of the model, like, does it differ with respect to consumables, like things that we frequently purchase, like vegetables or things, versus something like a TV, mobile, like probably the So have you tried it on these different types of commodities?
Okay, right now I tried with a sample of data, like our overall sample of data in the e-commerce domain. So like we didn't have like grocery related much items over there. I think general purchases we had, but yeah, to answer your question, we didn't do that. That
Any questions? I like this idea, but there need to be trimmed here and there.
Okay.
You have taken recency, frequency. You haven't considered about monitoring. So there's a concept called RFM in marketing.
Yeah, yeah.
So you've missed the monetary part, the price of the product.
Okay, okay, okay.
So actually there is one case in our professor.
Mm-hmm.
Where Flipkart used RFM to predict the customer churn.
Okay, nice.
It's right market basket and it's similar to market basket, but you're using just the frequency and the recency. You missed the major part of monitoring.
Okay.
You have to consider that before taking it forward.
Yeah, definitely.
Yeah.